Alright, this is a statically indeterminate problem for AEM3031. My name is Michael Lammers, the man behind the camera is Lucas Hash. So basically what we have here is two different materials, three different blocks. One material up top, flexibility F1, and then two of F2. We have reactionary forces on the top wall, two reactionary forces on the bottom wall, RB, and then a force in the middle. So to start solving this problem, first we're going to do the force balance, which if you look at the statics, turns out to be simply RA equal to F plus 2 times RB. Next we'll go on to the force displacement relations. So this is actually going to be, we'll call this equation 1. We'll do force displacement, first one, delta 1, it's going to be equal to F1 times the reactionary force at A. We'll call this 2A. Delta 2 is going to be equal to F2 times RB, or if we're going to substitute in right away, this is also equal to F2 times RA minus F, all that over 2. Lastly, our compatibility equation, we'll call that number 3. It's going to be delta 1 plus delta 2 equals 0. They're equal and opposite, so pretty simple. All right, to start solving, we have our three equations. Can you see over here? Is that okay? All right. Just outline this. We're going to take equation 2 plus equation 3, and we're going to set it equal to 0. By the way, our objective is to find the reactionary forces at A and B. So we just plug it in right away. F1 times RA plus F2 here. I'll use the substituted equation part of 2b. RA minus F over 2. And this is going to equal 0. And if we start doing the algebra, the point of this is to solve for RA. So if we work this down, 1RA plus, we'll just distribute F2. And now the messy part, solve for RA, is that we're going to have this F2F, bring that over the other side. To F1 plus F2, this is going to be over 2. It's a lot of algebra, but this is essentially going to be equal to 2F2F over 4F1 plus 2F2. 2's can cancel. So I'll move this up here because it will be important. This is part of our solution. RA equals F2 times the force in the middle all over 2F1 plus F2. All right. Now to solve for RB, it's actually pretty simple because we can go all the way back to equation 1. So we'll just have RB. So you can call from RA, you can use, yeah, we're just going back to equation 1 here. F2F over 2F1 plus F2 minus F. This time we're going to be dividing it by 2 because of just solving for RB in that equation. So, simplify this down. I'm going to actually multiply this side, or this F2 component, by 2F F1 minus F2 over itself. And once you distribute the F over 2 into this fraction, we can actually subtract F2F from each side, leaving just 2F1F. Negative 2F1F. All over 4, because we have the 2 over here, plus F2. This is equal to RB.
What does the fuck say? What the fuck say? What the fuck say? What the fuck say? What does the fuck say? The secret